building this CNC. It's all documented online as far as the assembly instructions, but I did want to kind of document a little bit of it. So basically I set up a time-lapse camera for the entire build, and this was spread out. Let's see, we had some sporadic time here and there to work on this. It was 3 7-hour days when it was all said and done for the two of us. Now, we weren't like, crazy working hard or anything. It was just a casual build, and very not difficult. I mean, it's all documented with the instructions, so you're just basically following instructions. Now, I did have to go back and forth on the instructions because I'm kind of building a mix between two of their common models. So they have a 4x8, which is very common, and then a 5x10, which is very common. I'm building the 4x10 or a 4x10 CNC. So I went with a 4-foot width instead of 5 because there's literally nothing that I can think of for a 5-foot width other than, say, something completely random like maybe a 5-foot diameter circular clock, which I'm never going to do. I don't see myself ever doing. And then the other argument for a 5-foot width is for Baltic birch. Baltic birch plywood typically comes in 5-foot by 5-foot sheets. To this day, I have never worked with Baltic birch. There's no place anywhere near me, none within like a 3-hour drive that I know of, that maybe a 2.5-hour drive that can even get or order 5-foot by 5-foot Baltic birch. I just never use it, never work with it. Don't really want to plan on a large project or a large tool like this, like a CNC machine, for something that I'm never going to use. So the 5-foot width, all I use is 4-foot by 8-foot plywood. So beyond that, all I can think of is tabletops, long, large slabs of lumber. I think 4-foot should be, it should be just fine for basically everything that I'm going to do. So that's why I went with 4 feet for the width. Now for the length, I have a couple different goals with the CNC machine as far as what I want to be able to cut. So I did go for a 10-foot length because I want to, number one, be able to cut a full 4-foot by 8-foot sheet. Number two, I want to be able to plan for in the future the rotary attachment. That's something that's very intriguing to me, but I didn't go with it right off the bat because I want to get this whole system familiarized, and I know that these machines are so modular, so adding the rotary down the road should be seamless, so there's no need to get it right this second. But I do want to plan for the space. And then also I do want to have one of the biggest things that I want to be able to do is have a vertical table to do joinery on both, small stuff like, say, this stuff the size of like a table leg, the end grain part of a table leg, maybe a 3-foot by 3-foot square. That's small stuff. But also I'm thinking like big cabinet sides. So like, let's just say like a blanket chest, a green and green blanket chest. All of the sides are box joints, through box joints, finger joints, and being able to variable space that, program all of that on the computer and have the CNC machine cut it out. That's fascinating to me, and I think that's something that I really want to explore. The only limitation with that is the distance from the floor to the bit, basically. So if it's a really long piece, then you obviously can't stand that on end. But again, we're talking about odd scenarios where that wouldn't be the case. So anyway, a vertical table, 4-foot by 8-foot panel, and then also the rotary attachment. All of that added up is about 10 feet in length. All right, at this point, the frame is complete. It is square and it is positioned in the shop where I want it to be positioned. So we can level the feet. And this was a very, very easy process. I'm using a Stabila. This is a, what is it? DP. No, it's a Tech 500 DP. That's what it is. The DP stands for Digital Protractor. And it's basically a level on steroids. This thing is so cool. So the way it works is you set it in, you take a reading in 2 different directions on the same spot to calibrate it for a 0 measurement for a perfectly level. And then you can set it in place wherever you want to level, turn on a audio feedback button so it'll start beeping, and the frequency of the beep changes the closer you get to 0. So you can just set it in place, let it start beeping, and then adjust the feet as necessary without having to keep stopping and going back and looking at the level. It'll let you know from audio feedback how close you get to zero until you do get to zero. So I went around the entire whole frame here. So I leveled the left side, leveled the right side, got those perfectly level, and then used the device on top of the gantry to get the left and right side level to one another. Now, you don't really have to do this. All you need is everything coplanar, so it's all on a flat plane. It doesn't necessarily have to be level, but I'm already here, so why not? So in this case, on the left side, I had to lift the left side up by the same amount. All 3 feet were lifted the same amount to get it close to or level with the right side. And this took like 5 minutes to get the entire machine not only flat and planar all the way around, coplanar all the way around, but perfectly level. So that was pretty cool. Next up is the rest of the gantry. So we have to put the linear rails, the rack and pinion, or the rack on top. What else? The Z-axis gets installed. Now the Z-axis comes pre-assembled for the most part, which is really nice. That helps out a lot. Once that's installed, the motors are installed, the cable rack, then all the cable attachments, the cables rather, you run the cables, hook up the sensors. So this has sensors to stop it from running into the end stops in all 3 directions, X, Y, and Z, so you don't over travel and cause damage. So those are all hooked up, the motors are all hooked up, the electronics boxes are installed. So there's one box for running the motors, so the actual motion of the machine, and that's powered by a 120 volt circuit, so just a regular wall outlet here in the United States, North America. And then the second box is for the spindle power, so that's a 240 volt circuit. So you need 2 different power sources for this setup. There is a regular wall outlet next to the machine, but I don't want to have any wires dangling or hanging on the floor on the front left or right side. So my plan is to drop a pair of circuits from the ceiling on the back side and then run them right through the cable management. So I'll have a 120 volt circuit as well as a 240 volt circuit drop down from above. That'll put all of the wires contained on the machine. So at the end of the day, if we're running something that gets a little bit messy, dust collection doesn't get it, you can just sweep up all the way around the machine and not have to worry about any wires whatsoever. We've got the CNC machine running completely, and I've already taken the time to tram the spindle. So just clamping a board up here and running the spindle in a series of left and right and then forward and back to make sure, to get an example so I know if I need to adjust this in any way. I've already done that, everything's good to go. Next up is the spoil board, and there's a couple options to attach the spoil board to this frame. The first option is with these roll-in T-nuts that you can push into these slots, and it's a T-nut, so you have a spot for a bolt to go into. So you can put them anywhere and then bolt anything to the aluminum extrusion. And typically you'll see a piece of MDF laid down, some holes cut for those bolts and roll-in T-nuts to go top down into the top of these aluminum extrusions. However, that's kind of a pain in the butt, and every time that the spoil board needs to be changed, that same amount of annoyance will have to be repeated over and over again if I go that route. So instead, I'm going to use the same method, but we're going to attach sacrificial pieces to this vertical side or vertical front of each one of these webs. Basically a 2x4 is going to attach to the vertical face. We'll surface the top of those so that they are all parallel or coplanar, I should say. And then at that point, we can lay the MDF on top of that and screw just regular countersunk screws right into the 2x4. That's going to be way easier long-term to make any type of adjustments. This is one of those roll-in T-nuts, and it's got a threaded hole and a push ball. I forget what it's called, but that ball has some flexibility in the backside so that you can push it in, and it's kind of spring-loaded. That's what it is, spring-loaded ball. So basically, this system allows you to put a nut anywhere in the aluminum extrusion, which is great. And this is the particular length that we're given for the waste board. So that means this countered board hole has, I think it was about 1/4 of an inch, maybe about 5/16 of an inch of meat on the bottom of that hole. So there's plenty enough to grab to as the bolts tightened. So this is a great setup because you can mount stuff anywhere. But it's when you have like 5 or so that are in a line on a board, well, like assembling or screwing a waste board down, it's going to be a little bit crazy to try and get everything to line up. But anyway, here's a test of just one to see how well one would hold, and it holds really, really strong. I started to rotate it here, really putting some force on it. That's plenty strong enough to hold this to the frame, especially considering a 49-inch long 2x4, which is what we're using. There's going to be 5 of these holding each one of the 2x4s in place, so plenty strong enough to build up a sacrificial surface to mount stuff to in the future. Here you can see the 2x4 is mounted to the frame, and we used a drill press with a fence on the drill press table to drill all the holes in line with one another and position of those so that once they were installed, once these boards were installed, the top would be about 1/4 of an inch, 3/8 of an inch higher than what it needs to be. And then I can use the CNC machine to mill all of the tops of the 2x4s coplanar and close to the top of the aluminum extrusion. Now for the bit, I'm using a 1/2-inch compression bit. Compression really doesn't matter in this case because the cut quality does not matter. We're just trying to get a flat reference face. This threw chips everywhere, so I really got to get dust collection going. As a matter of fact, during this cut, it actually threw some of the chips right at the camera, which was like 15 feet away. A large chunk flew out. So there's another reason for dust collection, to stop shrapnel from flying at you. But the machine itself was used to mill everything nice and flat, coplanar, and very close to the top of the aluminum extrusion. Then the MDF sheet can be installed. And the benefit of doing this is, like I said earlier, once we need to change this MDF sheet in the future, it's going to be way easier to do that by just removing some countersunk screws, which is how we're attaching this, rather than having to deal with all those blind T-nuts once again. So it's just for ease of convenience long term. And like I said, we're just countersinking holes and drilling down, or securing it rather, with some just regular screws. This is a good stopping point for this video. The machine is completely built. It is operational. Don't have the spoil board surfaced just yet because I am waiting on dust collection, so I still have to do that. There's plenty enough room in the back for the rotary attachment. When that comes, there's plenty enough room in the front for the vertical table, which will be sooner rather than later. I'm really, really excited about having a vertical table for this to do joinery and all kinds of fun stuff. I'm really, really looking forward to that. What else do we have to do? Oh, there's no hold down options inside the spoil board just yet, so I'm going to figure that out. And I am going to continue this series on this particular series is going to be nothing but this machine. So stuff about the setup of this machine, the software side, not project specific, just machine specific. So that'll be a good way to categorize things and you'll be able to reference a whole series rather than trying to find random titled videos. That's it. You guys take care. Have a great day. Be sure to subscribe if you're interested in the rest of the series so you don't miss that. Check out my website. Go to jayscustomcreations.com/newsletter to sign up for my email.